Howdy and welcome back. So the last video in this lesson is going to be on traversing a linked list. So traversing a linked list. Remember that the entry point to our linked list, so the sequence of nodes, is going to be stored in the singly linked list heads data member. Remember that tail is simply going to point to the last element and it's going to serve as a way to quickly jump to the end of our linked list. Notice that the access to any element between head and tail exclusive is going to require a traversal. Unlike arrays, we don't have the ability to jump to, say, the nth element. Instead, for instance, if we just look at this, if we want to access the element or get to the node storing 12, in order to do so, we're going to have to visit the head, follow the head's next pointer to visit 11, the node storing 11, and then follow its next pointer to eventually arrive at the node storing 12. There's no one hop there. There's no pointer arithmetic that we can do to essentially offset into the third element of this sequence of nodes, because each node object is kind of scattered throughout the free store. They're not adjacent to one another. So in order to hop from one region of the free store to the region where, say, the subsequent node is stored, we're going to have to follow the next pointers. Now, before we get into the actual traversal process, I just want to point out one common mistake, and that is people will sometimes attempt to use the head pointer to traverse the linked list. The problem with this is that if we were to change head to point instead of at the first element within this sequence to, say, the second element as shown in this diagram, we've now lost all references to this node. Head was our only way to get into the sequence. We've now moved head to the subsequent node, and notice that there's no previous pointer here, so we can now never get back to where we came from. So do not use head to traverse the list. This will cause a memory leak since you'll lose your entry point into that list. So we can never call delete on the node storing the integer value of 7 because we no longer have its address or a way to access it. So instead, anytime you're traversing a linked list, what we're going to need to do is create an additional pointer and use that pointer to traverse the linked list. So in this case, we have node pointer current, which is going to be initialized with head. At this point, head and current point to the same node object. Notice that we can move current one node forward by writing current, and you saw this in the destructor, is equal to currents next. So that takes this value and assigns it to current. Well, the value stored in currents next is the address to the next node. So by assigning current the address to the next node, we've effectively moved to that node. So we can continue this process, and we could continue doing so of just assigning currents next to move from one node to the next. And we can continue doing this until we arrive at the null pointer. For instance, once we've arrived at the null pointer, we know that we have visited every single node within this sequence of nodes, as shown here. So we know we've reached the end of our sequence when current becomes assigned with the null pointer. So there are a couple things to consider. It's not always going to be the case that we're going to want to walk through and visit every single node within our linked list. In fact, if we were adding to the end of the linked list, we'd like to actually stop on this node, so here, opposed to going through to the very, very end, which in this case is getting us to the point where current's pointing to nothing. Because at this position here, if we wanted to tag something on to the end of the linked list, we could. However, if we've gone past that element, we'd have to start at the beginning again to walk through the nodes in the sequence to get back to the end. Or in this case, we could just use the tail pointer. But anyhow, what I'm trying to point out is the idea behind these traversals could be, one, while I'm not at the end of the list, I want to move there. And we just move there by continually moving current from one node to the next until we're at the end. Alternatively, we could construct a loop that would essentially communicate while I'm not where I want to be, I need to move to the next node. And I'll let you think about this in the activity corresponding with this video of inserting, say, a node into a linked list in order. So again, if you can look at, say, the values of the node. I mean, there's the possibilities to govern this traversal process are effectively endless. You only want, so the question becomes, under what condition do you want to move to the next node? This can govern that. And again, how you craft that conditional can dictate whether or not you're moving from one node to the next. And one additional thing I'll say is just be careful that you don't go past where you want to go. For instance, if I wanted to hook up a node between 11 and 12, let's say it has the value of, I don't know, 29. Notice that I can't do it from that node. Instead, I have to visit this node. So one before the position where I want things to get hooked up, because I need to move this node's next pointer to point to that. And then I also need to move the node before, say, 12, so that storing the value of 11 to point to this new node. And then that effectively destroys that relationship. And now we've absorbed the nodes containing the value 29 into our linked list. So where am I getting at here? Well, if we wanted to insert, say, at the third position, we'd have to stop at the second node to do that. And notice after this operation, that would become the third node, and that would become the fourth. So again, it's all going, how you're constructing this loop to determine when you need to move to the next order is going to be highly dependent on what you're looking to accomplish. So don't just look at this as like a cookie cutter. I'm going to drag and drop that into my program and it's going to, solve all my issues. No, you have to think about the actual traverse. What am I trying to accomplish? Where am I trying to get to? And you're going to have to craft a conditional that's going to get you to that location.